Hi, my name is David Platt, and I lead the customer success team here at Tilia Labs. Today, I want to demonstrate the new optional scripting module in Tilia Phoenix 7.0 that makes Phoenix even more powerful, customizable, and dynamic. Let's dive into a use case example of how scripting can be used in Phoenix to create custom production marks. In this example, we'll see how scripting provides access to drawing tools within script marks, and look at how scripting inside an Imposition AI profile can help us dynamically assess layouts and update product properties. Here's our setup. We have a folding carton job that Phoenix's Imposition AI tool tells us would be drastically cheaper to produce if we can combo the products on one press form. But we know that if they're on the same press form, that might cause issues in finishing due to all the products being mixed on the same sheet. Since the artwork does not include a separator or other way to identify it, there's no way to ensure products are clearly identified and kept separated in finishing. Tilia Phoenix provides a solution to dynamically build just about any mark we need. So we'll create bleeder marks or product identification marks that will easily allow us to see which SKUs are which and solve any potential issues downstream. Here's how the job looks in Phoenix. It's a relatively simple job with only 9 SKUs, but some of them look similar. If I run Phoenix's plan tool, you can see there's about a $10,000 cost difference between the comboed result and the result with only one product per form. That makes sense, as the combo job only needs one set of plates, one make ready, and one press run. However, we need to ensure each product is uniquely identified on a combo sheet to ensure issues don't happen downstream. So let's choose the combo job and then add our script mark. This is where the magic really happens. Now, there are several different types of product identification or bleeder marks being used in the industry. But let's take a look at the example we have built. You can see the script mark creates a set of colored bars that are unique to each product on the layout, and they're positioned to intentionally overlap the die cut line. This way, when you look at a stack of die cut cartons on a pallet, you can clearly see on the side of the stack when a product is mixed, because the bleeder mark won't match with the rest of the stack. As you can see, I can change the order of products in the layout, and the mark remains the same for the same product. The mark is being driven by a product property that's dynamically set when we apply a plan from Imposition AI. You can see as I isolate the product that I can change the bleeder index parameter, and the mark updates accordingly. Now that you see what it does, let's take a look at how all this works. Now, even if you aren't a scripting guru, I hope you stick around to see that it's not that complicated. First, we need to assign a unique product property to each product in our layout. We could try to do this in our CSV import, but there's no way to know what products are going on the layout. So outside of scripting, there's really no way to assign this value. The script starts by assigning a property name. This is the name of the property we'll be updating for the product later in the script. Inside of the function, we look inside the job and set up a loop to cycle through each layout, one at a time. While looking at the layout, we find all the products in the layout, make sure that they exist, and then loop through the products. Now, for each product, in order, we set the product property and use the product index to set a value. So, this is how we get the product property. These Imposition AI scripts are run when the Imposition AI result is applied in Phoenix. Now let's look at the mark. First, we set the total width and height of our mark. Then we convert these values from inches to points, since our script marks always use points. The script then sets the context to a product, since this is a product mark. Next, we grab our bleeder index that we set with the first script. After making sure the index is set, we create a rectangle that will hold our mark. We then create a drawable painter, which we will use later to do the actual drawing. Just to give some background here as to why we're doing what we're doing, we could have 9 or 12 or even 16 products on one layout. Our mark isn't big enough to hold 16 individual marks, so we use some clever logic here to make sure the colors on each product are unique, but only have a max of 2 colors at one time. We vary the number of colors and number of bars, but still keep the mark as simple as possible to make it easy to recognize the products in the stacks. Since this is all scripted, we could modify the setup however we want. This is the rationale behind this setup. We define the colors that we will be using with their CMYK values, and then initialize variables for each of our 2 colors. We also create an index variable, which we will use to keep track of where we are with each mark. You'll see why that's important in just a moment. Next, we set which colors should be used based on the bleeder index. For products with indices up to 5, we'll use the colors cyan and magenta. Then for products with indices 6 to 10, we'll use magenta and yellow. If there were more products, you'd see they'd use unique colors. We then set our index value using the modulo operator. Basically, this tells us for each group of 5 indices, which one is it? For instance, bleeder index 6 becomes index 1, 7 becomes 2, bleeder index 8 becomes 3, and so on. Now we're ready to draw the mark. We pass all the info we have up to this point into our draw mark function. Now, keep in mind that this mark is running once per product. So as we go through, we're only dealing with one product along with its bleeder index and set of colors. We start this function by finding out how many bars and spaces there should be in the mark. We then use that to calculate the width of each bar. We then calculate where the first bar will start based on the total width. Finally, we're ready to start drawing bars. We need to draw each bar individually, so we loop through the total count we just made. We'll be alternating bars and empty space and bars and empty space. So if the number is odd, we'll tell the script to continue, which just skips the rest of the loop. If the number is even, we'll find out which color it needs to be by using the modulo operator again to find out how the number is divisible by 4. I'm not going to explain exactly how this logic works, but this allows us to cycle between the two colors as the count increases. Now we have the color of the bar, the size of the bar, and are ready to finally draw. We set the painter's brush to the color we just set, and then create a rectangle in the correct location. Finally, we draw the rectangle and then loop back through any remaining bars we need to draw. So that was a bit more complicated than the Imposition AI mark, but hopefully you're able to follow along, and more importantly, see just how powerful, dynamic, and customizable these scripting marks can be. Now that we've reviewed the scripts, let's take a look at where and how to add them within Phoenix. We'll start with the Imposition AI script. Open the Imposition AI window and click the drop-down to create a new profile. Configure the profile however you'd like, and then choose the Scripts tab. From here, we can load the script from the disk. Once loaded, we can review and even edit the script directly within Phoenix. Click OK to save the profile, and you're ready to use your new Imposition AI profile. Keep in mind that the script is run at the time you apply your planned result. As for the mark, it's just as easy. Navigate to the Marks window and click the Add Mark button. Choose Script as your mark type and use the Smart Placement option applied to a product. Click Continue and load the mark from the disk. Then configure your print settings, set your mark name as well as placement on the product. When you're ready, click Done and you're all set. Thanks for watching and spending time with Tilia Labs today. We hope you found this helpful, and as always, if you have any questions or feedback, leave us a comment or send an email to info@tilialabs.com. For more information, check out docs.tilialabs.com. Thanks again, and we hope to see you again soon.